Hello everyone and welcome to this session. I'm Anika, your instructor, and today I'm going to be teaching you about how satellites work. Feel free that at any point in the session you can ask me any questions. Let's just dive right into our topic. So, I want to know, what do you already know about satellites?
Satellites are the kind of machines that orbit around the Earth and receive and send information to the Earth.
So, let's go into a deeper dive. First of all, what are satellites? So, a satellite is an object in space that orbits something larger than itself. Let's just go through some examples of satellite. Like we've discussed, Sputnik 1, Aryabhatta, and Explorer 1 were the first few satellites to be launched in 1957, 58, and 75. The first concept of a satellite that we are going to learn about are orbits. Aren't you wondering, how do satellites stay in orbit? If it was so easy to orbit something, couldn't you just put a toy in space and it would start orbiting in Earth? Well, it's not how it works. Every launch vehicle has something called an escape velocity. The escape velocity of the Earth is around 11 kilometers per second. When you have your launch vehicle here, it needs to go fast enough to escape the Earth's atmosphere. You might think, okay, so it'll start orbiting now. But won't this orbit end up crashing inside to the Earth again? Because the Earth is always pulling it? No, because of the orbital velocity. There are 3 types of orbits based on the inclination, 2 based on the shape, and 3 based on the altitude. And so now we will be moving on to the main parts, diving inside the satellite. So the 6 main components that a satellite needs are the power supply, the flight computer, the bus structure, the mission payload, the form of communication, and the thermal blanket. So let's look at this diagram. You can see this bus structure over here. This is a sort of like a CubeSat. And this image below is actually a more detailed image of what a flight computer might look like. Why do you need input-output? Because when we study space, we need to understand that data. That's input from outside. And your output is digital data. Scientists analyze those data. Now let's jump into the power supply. You see those little square sort of things? These are the solar cells, and when you put them in a grid together, it becomes a solar panel.
If it's cloudy or something, then how will we get this? Then it won't work, right? If it's raining or something.
When it's cloudy or when it's raining, yes, there's hardly any solar power. Especially when it's raining, there's no solar power because the sunlight cannot reach your solar panel. You know what atoms are, basic substances. You know what elements are, types of atoms. Every element has 3 particles, protons, neutrons, and electrons. If you change the number of neutrons, your atom is going to get heavier. And when the mass changes, it might also get unstable. When you change the number of neutrons in atoms, you make an isotope of that atom. Some isotopes are unstable. It becomes radioactive, which means that it keeps splitting up until it's balanced again. When it splits up, it releases a lot of heat energy that we can use as electric power by converting it. Let's move on to a fun Q&A session. What power source do you think the satellite uses? Second, what do you think it uses for communication? And third, give an example of the bus structure.
Uses solar power.
Solar arrays.
It's the receiving antennas and the transmitting antennas.
Antennas are used for communication. Give one example of the bus structure.
The beam-forming networks.
Wow, you got that one right. The easiest question there is. I want you to tell me which one of these, 1, 2, or 3, is a CubeSat satellite. Which one? Tell me together. Yes, it is the third one. Now we will be moving on to my satellite. So this here is my satellite, and I created it to observe the Earth's atmosphere. I'm going to show you the parts of my satellite, and let's see if you can connect them to what we learned previously. So first, I'll just let you guys see the inside of my satellite one by one. Next, we have the flight computer. So this is the ESP32 Very Large Scale Integrated Circuit Chip, VLSI. You see this main thing in the center, this little circuit sort of thing? This is actually ESP32. These 3 are sensors that I've put as my mission payload. And those are the components of my satellite. So before I demo my satellite to you, I want to know if there are any questions you guys have. Yes.
We have to use this power module when we already have a battery and a solar power panel as a power supply?
Wonderful question. So, when I have these solar panels, they collect the solar power and convert it into electrical energy, and we need to give that energy to the battery. But we can't just connect these wires to that battery because that's not going to do anything. We need something that can transfer the power from the solar panels into the battery, and that is what the power module does. You can see all these red lights are glowing inside my satellite, which means that everything is turned on. So this is the satellite, which is showing up in my Bluetooth map, and this is the data. And you can see this graph, right? I was using my satellite before as well, and this is some previous data that was recorded. Let's say that I blow my air into this. So what do you think is going to happen? The humidity is going to increase, right? Up to 57%, right? 71%. If you could explain what your idea for your mission is.
I would like my satellite to go to Jupiter and find if there were any organisms or anything in Jupiter.
I would like to send a satellite to any planet revolving around Alpha Centauri and figure out whether humans can survive in that planet or not.
Thank you so much for joining in, and I hope you enjoyed the satellite session. I hope you learned some new things, and I can't wait to see what satellite mission you come up with. Bye!